What if the ugliest minerals in the field were actually pointing you toward hidden gold? Experienced prospectors often pay more attention to indicator minerals than to visible gold itself. Minerals like pyrite, magnetite, hematite, chalcopyrite, and arsenopyrite can reveal the geological conditions where gold is more likely to occur. These minerals tell the story of ancient hydrothermal systems that transported and deposited valuable metals deep within the Earth's crust. While no single mineral guarantees a gold discovery, recognizing these natural clues can help narrow the search for promising ground. Today, we're uncovering the hidden mineral signs that have guided prospectors to some of the world's most famous gold discoveries. A cracked rock, a flash of sunlight, then gold. Not everywhere, not for everyone, but for the few who know what to look for. The Earth starts whispering secrets, and tonight, you're about to learn 5 mineral signs that changed ordinary people into treasure hunters. Some ignored them, some walked past them, others became rich because of them. Welcome to Pro Gems, where ugly rocks become hidden fortunes, and where the next stone you pick up could change everything. Before the gold appeared, there was always a warning, a clue, a silent signal buried inside the earth for millions of years. Most people never notice it. That's why gold stays hidden. But experienced prospectors, they hunt differently. They don't search for gold first. They search for the minerals around it, and the first sign has fooled people for centuries. Number 1, pyrite, better known as fool's gold. Pyrite. The name sounds harmless, almost embarrassing, but here's the shocking truth. Real gold deposits are often found near pyrite, sometimes extremely close, because both minerals can form under similar underground conditions. Hot fluids, pressure, ancient volcanic systems, the perfect recipe for buried treasure. At first glance, pyrite looks cheap, too shiny, too yellow, almost fake. Before knowledge, people threw it away. After knowledge, miners started following it, and some discoveries became legendary. Picture this: a lonely prospector in the mountains, rain falling, cold wind, no gold for weeks. Then suddenly, tiny metallic cubes inside dark stone, not gold, pyrite. Most beginners would quit right there, but old miners, they keep digging because pyrite often acts like a trail marker, like footprints leading deeper underground. And sometimes, microscopic gold hides inside the pyrite itself, invisible to the naked eye, locked inside for millions of years. That's the terrifying beauty of gold hunting. The treasure may already be in your hand, and you still can't see it. But there's a dangerous mistake many people make. They trust color alone. Huge mistake. Real prospectors study behavior. Pyrite breaks sharply. Gold bends softly. Pyrite sparkles hard. Gold glows warmly. One is brittle, the other survives centuries underwater. And here's where the story gets even stranger. Some abandoned mines once considered worthless were reopened decades later. Why? Because old miners ignored pyrite zones. Modern testing revealed hidden gold concentrations nearby. Millions of dollars, sleeping beneath forgotten dirt. Imagine that feeling, walking across land people abandoned generations ago, only to discover they quit inches away from wealth. That happens more than you think, and the deeper you go into gold country, the more these patterns repeat. But pyrite is only the beginning, because the second mineral looks far less impressive. Dark, heavy, sometimes ugly, yet experienced prospectors become extremely excited when they see it, especially near quartz veins. Number 2, magnetite. Magnetite black sand. Heavy streaks near rivers. Tiny magnetic grains. Most tourists ignore them completely. Huge mistake, because magnetite often appears in areas shaped by ancient hydrothermal systems, the same systems capable of transporting gold. And rivers reveal this secret beautifully. Gold is heavy, magnetite is heavy too. So when flowing water slows down, both minerals settle together, quietly, patiently, waiting. That's why experienced gold hunters study riverbends carefully, not randomly, never randomly. Before discovery, the river looked ordinary. After discovery, every dark streak became suspicious. Some prospectors even carry magnets before they carry expensive tools, because black sands can reveal hidden concentration zones. And concentration means possibility. But there's another reason magnetite matters. It tells a geological story, a violent one. Ancient magma, extreme heat, mineral-rich fluids rising through fractures deep underground. The Earth was not calm when these rocks formed. It was erupting, breaking, transforming. And sometimes, gold traveled with those fluids, locked inside quartz veins nearby. Now imagine standing beside a freezing river in Alaska, or deep in forgotten mountain valleys. You kneel down, wet gravel everywhere. Then you notice black streaks collecting behind larger stones. Heavy material, different from normal sand. You test it. The magnet reacts instantly. Your heartbeat changes, because now the ground is talking to you. And if magnetite appears with quartz fragments, things become very interesting, especially white quartz stained with rusty colors. That combination has started treasure obsessions for generations. Some became rich, others lost years chasing rumors. Because gold hunting is psychological warfare, hope versus patience, logic versus greed, and nature loves confusing humans. Sometimes the signs are perfect, yet there's no gold. Other times, the ugliest location hides unbelievable value. That uncertainty keeps prospectors addicted. But another mineral sign may be even more important than magnetite, because this one creates color changes impossible to ignore. Red, orange, rusty brown, like the earth itself is bleeding. Number 3, hematite. At first, it doesn't look valuable, not glamorous, not luxurious, no sparkling crystals, no bright reflections, just iron-stained rock. But experienced miners stop immediately when they see heavy hematite alteration zones, because oxidation tells stories, especially in old gold systems. Before exposure to air, many gold-bearing sulfide minerals stayed hidden underground, but over thousands of years, water and oxygen transformed the rock. The result? Rust-colored zones, red fractures, burnt-looking surfaces, nature's warning sign, and sometimes nature's invitation. Entire hillsides in famous mining regions turned reddish from iron oxidation. Most travelers saw ugly terrain. Geologists saw opportunity. One abandoned canyon in Nevada looked completely dead from a distance. Dry, hostile, worthless. Then samples revealed gold nearby. Not because gold was visible, because the surrounding minerals were screaming clues. That's the secret nobody tells beginners. Gold rarely introduces itself first, its neighbors do. And hematite can become one of the loudest neighbors of all, especially when combined with quartz. That combination again, quartz and iron staining, a legendary pairing in gold country. Some of the richest discoveries in history started exactly that way. But there's a darker side to this obsession. People become consumed by what if. One red rock becomes 10, then 100, then years disappear. Because hidden treasure changes human psychology. It awakens ancient instincts, exploration, risk, hope, greed, survival. The same emotions that drove men across deserts during the great gold rushes. And tonight, you're beginning to see the world through their eyes. But we're only halfway through the list. Subscribe to Pro Gems, because the earth hides far more secrets than most people can imagine, where hidden minerals become treasure maps, and where ordinary stone can secretly hold unimaginable value. Number 4, chalcopyrite. At first glance, it looks almost magical. Metallic gold tones, rainbow flashes, purple, blue, bronze, like oil floating across water. Beautiful, almost too beautiful. And that's exactly why people underestimate it. Before understanding geology, many collectors kept chalcopyrite because it looked expensive. After understanding geology, prospectors realized something terrifying. Gold deposits often form in the same hydrothermal systems as copper minerals, including chalcopyrite, especially inside fractured quartz veins. Now imagine standing inside an abandoned mine tunnel. Your flashlight cuts through darkness. Dust fills the air. Then suddenly, metallic reflections shimmer from the rock wall. Not gold, chalcopyrite. Most beginners celebrate too early, but experienced miners become cautious instead, because this mineral signals a powerful underground process. Hot mineral-rich fluids once exploded through these fractures. Copper traveled there, iron traveled there, sulfur traveled there, and sometimes gold traveled there too. That's why old mining maps can become incredibly deceptive. Some tunnels chased copper, others chased silver. Then decades later, modern testing discovers microscopic gold hidden throughout the same system. Millions waiting inside overlooked rock. And this is where treasure hunting becomes psychological warfare again. Because gold rarely appears dramatically at first. No giant glowing nuggets, no movie scenes, just clues. Tiny clues, one mineral beside another, one stain beside quartz, one strange metallic shimmer in broken stone. That's how discoveries begin, slowly, quietly, almost invisibly. But chalcopyrite carries another warning. Some prospectors become obsessed after finding it. They stop thinking clearly. Every yellow mineral starts looking valuable. Every rock becomes suspicious. Entire mountains turn into possibilities. An obsession changes people. History proves it. Men abandoned families during gold rushes, crossed frozen rivers, died inside collapsing mines, all because the earth whispered one dangerous sentence: there might be more. That feeling still exists today. Even now, somewhere deep in the mountains, someone is staring at a mineralized rock, wondering if their life is about to change forever. And sometimes, it does. But the fifth mineral on this list may be the most shocking of all. Because unlike the others, it doesn't even look connected to gold. Not obviously. No bright metallic shine, no golden color, no dramatic sparkle. Yet experienced geologists pay very close attention when they see it near altered rock systems, especially in ancient volcanic regions. Number 5. Arsenopyrite. Arsenopyrite, cold silver color, sharp crystal forms, almost steel-like, and yes, it contains arsenic, which makes it dangerous if handled carelessly. But geologically, it's incredibly important, because arsenopyrite is one of the strongest indicators of hydrothermal gold systems on Earth. In some deposits, gold exists directly inside the mineral structure itself. Hidden, microscopic, locked away. Before laboratory testing, the rock looked worthless. After testing, it became extremely valuable. This changed mining forever. Entire regions once abandoned as failures were later reopened because arsenopyrite zones contain invisible gold. And invisible gold is one of the strangest ideas in mining. Think about it. Treasure hidden inside another mineral. Not visible, not obvious, but still there. Waiting for the right technology, the right knowledge, the right person. Now picture an isolated hillside in the American West. Wind moving through dry grass. Old wooden mining structures collapsing nearby. Everyone assumes the mine died decades ago. Then modern exploration teams arrive. They study altered rocks, quartz veins, iron staining, sulfur minerals. Then they find arsenopyrite. Everything changes. Suddenly, old waste rock becomes valuable again. Drilling begins. Testing begins. Hope returns. That's the power of geological clues. And here's the deeper lesson hidden beneath all 5 minerals. Gold hunting is not really about gold. It's about patterns, observation, patience, reading the language of the earth. Because the planet leaves fingerprints everywhere. Pyrite, magnetite, hematite, chalcopyrite, arsenopyrite. Each one tells part of the story. Separately, they may mean nothing. Together, they can become a roadmap toward hidden wealth. And that's exactly how legendary discoveries happen. Not by luck alone, but by understanding signs most people ignore. A rusty fracture, black sand near river bends, metallic crystals inside quartz, ugly rocks with strange staining. The average person walks away. A trained eye slows down, looks closer, and sometimes that decision changes everything. But there's another truth few people admit. Gold changes human behavior long before it changes someone's bank account. It creates obsession, dreams, paranoia, hope, fear. Some become rich. Others lose themselves chasing almost. Because nature never guarantees treasure. It only leaves clues. And that mystery keeps prospectors searching generation after generation, even today. Somewhere right now, a forgotten hillside may already contain gold. A dry riverbed may still hide flakes beneath black sand. An ugly quartz vein may conceal value nobody recognizes yet. That possibility is addictive, and perhaps that's the real treasure. Not just gold itself, but the feeling, the hunt, the moment before discovery. Before, it was just another rock. After, it became proof that hidden value can exist anywhere, even in places people overlook every single day. So next time you see strange minerals and broken stone, don't rush past them. The earth may be trying to tell you something. And if you enjoyed this journey into hidden geological secrets, subscribe to Pro Gems, because the next story may reveal treasures even experienced collectors are afraid to touch. And trust me, some discoveries should have stayed buried forever. Gold is not sprinkled across the land like dust. It is not gently laid down by rivers, and it is never deposited the way most people imagine. Gold is trapped by force, trapped by physics, trapped by moments in Earth's history when movement suddenly stopped. If gold were simply deposited, it would be everywhere. Rivers would spread it evenly. Floods would scatter it endlessly, and the planet would glitter indiscriminately. But that is not what we observe. Instead, gold appears in precise locations, repeated again and again across continents as centuries. Certain bends, certain cracks, certain layers of rock, and nowhere else. This is not coincidence. It is control. To understand gold, you must abandon the idea of placement and replace it with the idea of capture. Gold does not choose where to go. It is forced there. And once it arrives, it does not leave unless something stronger intervenes. The story of gold begins far deeper than rivers or mountains. It begins in heat, pressure, and chemical violence far below the surface, where fluids move through fractured rock like invisible highways. Gold does not exist as solid metal at this stage. It travels dissolved, atom by atom, carried by hot, mineral-rich fluids under immense pressure. In this state, gold is mobile, restless, temporary, but mobility is fragile. The moment conditions change, gold loses its freedom. A sudden drop in temperature, a shift in pressure, a chemical reaction with sulfur, iron, or carbon, a narrowing fracture, a dead-end crack. Any one of these is enough. When that happens, gold falls out of solution instantly. Not gradually, not gently, instantly. It solidifies where it stands, clinging to rock surfaces, coating fractures, filling microscopic voids. This is not deposition, this is arrest. Gold is stopped. And once stopped, it becomes one of the most stubborn materials on Earth. Gold does not dissolve easily. It does not oxidize. It does not break down under normal surface conditions. It survives erosion, weathering, and time itself. While surrounding rock crumbles, gold remains. As everything else moves, gold waits. This is why gold is not found evenly distributed. It is found where movement ended. The earliest traps form deep underground, long before erosion ever exposes them. Fault zones, shear zones, and fracture networks act as conduits for mineral-bearing fluids. These structures are not random. They form where the crust is stressed, broken, and repeatedly reactivated. Every time the Earth shifts, these zones reopen, and every time they reopen, fluids move again. Gold follows, but movement alone is not enough. For gold to be trapped, something must interrupt the flow. A bend in the fracture, a sudden widening or narrowing, a change in rock chemistry. When fluid enters a zone where it can no longer hold gold in solution, the metal is forced out. It plates onto rock walls. It accumulates in seams. It thickens layer by layer, event by event. This is why the richest gold veins are not the longest ones. They are the ones with interruptions, bends, jogs, structural complications, places where fluid flow slowed, stalled, or collided with resistance. Gold accumulates where geology hesitates. As time passes, uplift and erosion bring these deep traps closer to the surface. Rock fractures, mountains wear down, gravity takes over. Gold, once locked in veins, is released as host rock breaks apart. But even then, gold does not wander freely. Its density dictates its fate. Gold is heavy, far heavier than sand, gravel, or quartz. When erosion liberates it, gravity pulls it downward immediately. While lighter material washes away, gold sinks. It moves only when force is strong enough to overcome its mass. And the moment that force weakens, gold drops again. This creates a second generation of traps. In rivers, gold does not settle where water slows slightly. It settles where movement stops completely, at the base of waterfalls, behind large immovable boulders, inside cracks in bedrock, along natural riffles carved by turbulence. These are not deposits. They are capture points. Every successful placer location shares one thing: interruption. Water can carry gold only briefly. The instant flow loses enough energy, gold is pulled downward and locked in place. Once trapped, repeated floods only concentrate it further. Each flood removes lighter material and leaves gold behind, compacted tighter against the trap. This is why old gold locations keep producing. The trap remains even as the landscape changes. Ice introduces another layer of control. Glaciers do not sort gently like rivers. They crush, grind, and smear entire terrains. But even ice cannot ignore density. Under immense pressure, gold is driven downward into bedrock cracks and compacted layers. When ice melts, gold remains exactly where pressure forced it, often beneath layers of chaotic debris that disguise its presence. Many of the world's richest placer systems exist not because rivers place gold there, but because ice trapped it first. Understanding this shifts everything. If gold were deposited, searching would be a matter of coverage. Scan enough ground and you would find it eventually. But because gold is trapped, discovery becomes a matter of reading where energy died. Where did pressure drop? Where did flow slow to zero? Where did chemistry change abruptly? Where did movement collide with resistance? These questions form the real map. This is why so many searches fail. People look for gold where it could travel, not where it was forced to stop. They pan fast-moving gravels. They chase surface color. They follow myths instead of mechanics. Gold does not reward motion. It rewards stillness. The most productive locations often look unremarkable. A quiet bend with exposed bedrock. A shallow crack most people step over. A compacted layer beneath loose gravel. These are not dramatic places. They are subtle, and they are deadly effective at trapping gold. Once gold is trapped, time works in its favor. Every flood, every freeze-thaw cycle, every storm removes more surrounding material. The trap becomes cleaner. The gold becomes more concentrated. What began as microscopic particles becomes flakes, then nuggets, then legacy. This is why certain locations outproduce entire valleys. Gold is not evenly shared by nature. It is hoarded by physics. And this principle applies everywhere: mountains, deserts, jungles, frozen ground. The environment changes, but the rule does not. Gold moves only until something stops it. Then it stays. In the next part, we will go deeper into how these traps can be identified deliberately, how simple and affordable tools reveal where energy once died, and how reading bedrock, sediment layering, and structural clues transforms gold discovery from guessing into certainty. Because once you stop asking where gold was deposited and start asking where it was trapped, the ground begins to speak very clearly, and it never lies. Gold is trapped, and that single truth changes not only how gold is found, but how it can be collected intelligently as a side hustle. Once you understand that gold concentrates where energy stops, you no longer need luck, expensive equipment, or massive land access. You need restraint, observation, and discipline. Gold collecting, when approached through the lens of trapping mechanics, becomes one of the few side hustles where knowledge compounds faster than capital. This is where most people misunderstand gold collecting. They imagine endless digging, noisy machinery, or dramatic river scenes. In reality, profitable small-scale gold collecting is quiet, methodical, and selective. It is built around identifying natural traps that already exist and working them patiently. Gold does not reward effort, it rewards precision. As a side hustle, gold collecting works best when you target locations where gold has already done the hard work of concentrating itself. Bedrock cracks, natural riffles, compact layers beneath loose gravels, inside tight crevices where water once surged and then stalled. These locations do not require excavation, they require cleaning. This is why experienced collectors spend more time reading terrain than moving material. A single productive trap can outperform hours of random panning. When gold is trapped, it does not scatter evenly through sediment. It stacks, it layers, it locks into place. Removing only the loose material above it often exposes concentrated values beneath. This efficiency is what makes gold collecting viable alongside a regular schedule. You are not mining, you are harvesting what physics has already prepared. The tools required reflect this philosophy: a pan, a classifier, a small crevice tool, a brush, a snuffer bottle. These are not beginner tools. They are precision instruments. Heavy machinery moves material blindly. Hand tools allow control. When you are working a known trap, control is everything. You want to remove only what does not belong there and leave the trap intact for future returns. This is another overlooked advantage. Gold traps recharge. Every flood season, every heavy rain, every freeze-thaw cycle introduces new material into the system. Lighter sediments move away, gold settles deeper. A well-identified trap can produce repeatedly over years, sometimes decades, without being exhausted. That makes location knowledge more valuable than volume. From a side hustle perspective, this creates a sustainable rhythm: short trips, targeted work, predictable results. You are not gambling time against chance. You're exchanging understanding for consistency. Equally important is legality and access. Productive gold collecting does not require remote wilderness or risky environments. Many effective traps exist in public lands, recreational panning areas, and permitted zones where hand tools are allowed. Staying compliant protects the hustle and removes stress. Professionalism here is not optional, it is strategic. Gold collected this way holds value in multiple forms. It can be stored, refined later, traded, or sold depending on market conditions. It is portable wealth acquired through skill, not speculation. And unlike many side hustles, it leaves behind no digital footprint, no algorithm dependency, and no middlemen. But perhaps the most powerful return is not financial, it is perspective. When you collect gold by understanding traps, you stop fighting nature and start cooperating with it. You learn to see landscapes differently, rivers become diagrams of energy, bedrock becomes a record of force. Every location tells a story, and some of those stories end with gold waiting quietly where movement once failed. That mindset carries beyond gold. It teaches patience, pattern recognition, respect for systems larger than yourself. These are transferable skills in any serious pursuit. Gold collecting succeeds as a side hustle, not because gold is rare, but because most people refuse to learn how it behaves. They chase motion instead of stillness. They dig instead of read. They search instead of wait. Those who understand trapping do the opposite. They move less. They observe more. They let physics do the work. And that is why their results compound, while others burn out. Gold is not deposited, it is trapped. And for those willing to learn where and why that trapping occurs, gold collecting becomes not just viable, but quietly powerful. That is the difference between searching for gold and knowing where it must be.